Hello everyone. In today's session I would like to explain Java Collection Framework with examples. Collection Framework in Java is all about properly storing and manipulating lots of data. First of all, let's take a look at its structure. Collection interface is on top of it. List, queue and set interfaces extend collection interface. Sorted set interface extends from set interface. Array list, vector and linked list classes implement list interface. Linked list and priority queue class also implements queue interface. Hash set and linked hash set class implements set interface. And tree set class implements sorted set interface. Map interface provides implementation for hash map, linked hash map and hash table class. Sorted map interface extends from map interface and tree map class implements it. And arrays with collections class work under object class. So collection framework is an entire hierarchy diagram. Collection interface is the base for free and other. And collections is the class under object class. The main advantage of Java Collection Framework is reduces programming efforts by providing useful data structure and algorithms. Let's take a look at the 10 most known methods that are used with it. Add method adds an object to a collection. Add all adds another collection to the current one. Method contains checks if the collection contains the specified object and contains all checks if it contains the specified collection. Size method returns the number of objects this collection contains. ToString converts the collection to string. ToArray converts the collection to array. Remove method removes a specified object from the collection. And remove all removes a collection from the current one. And clear method removes all the elements from the collection. Collection interfaces are like enhanced and a much more powerful idea of Java array. An array can be treated as a base and simple idea for collection interfaces and classes that implement it. And for better and simple understanding, let's compare them one by one. The first and main difference between an array and an array list is array has a fixed size. We have to indicate array size while array instantiation right here or while array initialization right there. After that we cannot change the array size. On the other hand, array list has a dynamically changing size. So, while creating an array list, we may not indicate its size. We can store primitive data types and objects inside an array, but we cannot store primitive data types in an array list. For storing different data type inside an array, we declare the data type as an object. For storing different data types inside an array list, we can do it by default. But for properly data storing, we specify data type like an integer, for example, for the array list and indicate it inside angle brackets and by adding blank angle brackets at the end of the line before blank parentheses. For assigning value to an array while declaring, we can do it directly right here. But for array list, we should use arrays as the list method to do so. A unique feature of collection and array list is add method that is also overloaded and allows add an element not only by the end of the array list, like in this example, but also can add an element to the specified index of the array list. It is possible because the size of an array list is dynamic. And it is not possible in arrays because their size is fixed. Another collection's unique feature is remove method. It can remove an element from an array list by its value. Also, it can remove an element by its index. And there is no such feature in arrays because of their fixed size. For getting a value of an element in an array list, we use get method with an index number inside parentheses. But for getting a value of an array element, we just use the array name and index number inside the square brackets. For replacing an element as a specified index is inside an array list, we use set method, and inside it parentheses it needs to indicate the index number, comma, and the new value for that. For replacing an element inside an array, just need the array name and index number inside square brackets equal new value for that. For getting the size of an array, we use length method. To get a length of an array list, we use size method. Collections class with method sort we use for sorting array list as well as linked list and so on. And arrays class with the method sort we use for sorting arrays. For printing an array, we use arrays class with method toString, but we print collections just by their names. Array list internally uses an array data structure. So, for addition or removal operations, it needs time to internally create a new array. And for rearrange all the elements it contains. But linked list internally uses double linked list to store the elements, and it has additional 2 pointers per every element inside the linked list. Via these 2 pointers, elements are connected with links to each other, and because of that it has the name linked list. And while addition operations, it does not create a new array, it just adds a link to a new element beside the linked list. And while removal operations, it does not remove the element but just create new links to connect elements from both sides of the element that marked as so-called deleted, but in fact just bypass it with additional links. So the main point is, linked list is faster while addition or removal operations, and array list is faster for storing and accessing data type that need to be stored. Next is array list and vector class comparison, and they are both implement list interface. The main thing is, vector class is synchronized, which means only one thread at a time can access the code, while array list is not synchronized, which means multiple threads can work on array list at the same time. For example, if in multi-threading environment one thread is performing an add operation, there can be another thread performing a remove operation. That can cause a conflict. And for this situation there is a method from collections class. Collections synchronized list. And taking into consideration that array list is newer and faster, plus collections class has the method to make it synchronized, we use array list over the vector class, if the other way does not recommend explicitly. Next, I would like to talk about linked list class that implements QInterface. While linked list implements QInterface, it has the following differences compared with linked list class under list interface. Nor indexing and only parameterized so-called generic data type can be put inside. Insertion order is preserved. No get, set, insert or remove operations in the queue. Only FIFO concept, first in, first out, It means insert elements only at the end of the queue and it named in queue, and removes elements only from the head, it named dequeue. 4 new queue concept methods are added to the linked list and they are named offer, element, pig, and poll. Offer method adds value to the back of the queue, as a regular method add with only difference. Offer method will return false if it fails to insert the element on a size restricted queue, but add method will throw an illegal state exception. These operations are named enqueue. Element and pig methods return but do not remove the head element. And in case the queue is empty, pig will return null, but the method element will throw a no such element exception. Remove and poll methods both remove and return the head of the queue. These operations are named dequeue. In case a queue is empty, poll method will return null, but remove method will throw a no such element exception. Next, I would like to explain the differences between linked list queue and priority queue with examples. There is a linked list queue declaration on line number 7. In these 5 lines of code, we just assign values to it. And by printing value of the linked list queue, we can see that it preserved the insertion order. We can see it right here and there. In these lines of code, method poll is applied to all elements of the linked list queue, and we can see by retrieving element one by one from the top of the linked list queue that insertion order continue to be. We can see it right here. But priority queue works differently. First of all, while declaring it instead of linked list, we indicate priority queue. Offer method is the same, we can see it right here. And while trying to print it, we can see that insertion order is not preserved anymore. And FIFO concept does not work with priority queue, and we can see it right here. The main difference between linked list queue and priority queue is, while retrieving elements one by one from the top of priority queue, it rearranges them in priority order, in ascending order. We can see it right here. The same thing with string data type. But for code reduction, instead of multiple poll methods, we can use iterator. It has the following syntax. Iterator plus the collection data type string in this case plus name of the reference variable equal name of the collection dot iterator plus blank parentheses. And inside while loop reference, variable name dot hasNext method with blank parentheses. HasNext method provides iteration all over the collection it loops through and returns true if the iteration has more elements. And inside curly braces, just print method with poll method inside it for taking each element from the top of the queue. And again, it provides all elements in priority in ascending order. We can see the result of it right here. And finally, a character priority queue here is, for example, println method displays that no order is preserved in priority queue. But we can see use while loop as the most convenient way for iterate the collection. Inside the condition we indicate logical operator not plus the name of the collection and dot and method named is empty. It provides iteration all over the collection until the collection is empty. And the method poll again polls and removes each element from the top of the collection and displays it. And by passing collections dot reverse order inside parentheses right here, we can make it priority queue change from ascending order to descending one. So these elements will be in reversed order then. And we can see the result of it right here. Also, priority queue doesn't accept null value, and linked list queue shouldn't accept null value too. Set interface and sorted set interface classes have the following differences with classes under list interface. The main difference is, while ArrayList or linked list does allow duplicate values that we can see right here and right there, for example, the set classes cannot contain duplicate elements at all. Also, the set has no index inside. So if you want to have no duplication values inside the collection, then the set is the right way. In line number 18 we can see hash set declaration. With method addAll we put the array list that has duplicate values inside the hash set. And we can see right here hash set eliminates duplicate values. Also an important thing, hash set doesn't preserve insertion order. We can see it right here and there. Next variation is a linked hash set. Please pay attention that it is possible, instead of using addAll method for adding one collection inside another, just put the name of the collection inside constructor at the end, right here and right there, for example. So, linked hash set has only one difference from hash set. It preserves the insertion order. We can see it right here and there correspondingly. And finally, tree set not only eliminates duplicates value, but also provides the result in ascending order that we can see right here and there correspondingly. Hash set class is the most popular implementation of set interface. In terms of speed, hash set the fastest from them. Tree set is the slowest, and linked hash set is something in between. Hash set allows only one null value. Linked hash set also allows one null value, while tree set does not accept null value at all. Otherwise, it will throw null pointer exception. And the final part of Java collection framework is map interface and its corresponding classes. Map interface is not a part of collection interface, but part of collection framework. Map classes contain keys and values, and they are connected in pairs, where unique keys serve as indexes. Each key and value pair is known as an entry. Hash map is the fastest, tree map is the slowest, linked hash map is faster than tree map, and hash table is slower than hash map. Hash map doesn't maintain insertion order, hash table also doesn't, linked hash map maintains insertion order of entries, and tree map maintains ascending order of keys. Hash table is thread safe and synchronized. Hash map, linked hash map, and tree map do not. Hash map and linked hash map allow one null key and numerous null values. Hash table doesn't allow null key and null values. Tree map doesn't allow null key and allows null values. And the most important map methods are the following. Put method adds an entry, key and value. If the same key is already present, last value will be updated. Method replace updates the value of the key. Get method returns the value of the key. Contains key checks if the key exists in the map. Contains value checks if the value exists in the map. Method values returns all the value of the map. Method case set returns all the keys of the map. Method putAll put a specified map into the map. Method size returns the number of entries in the map. ToString converts map to string. Method remove deletes the key and its value. Method clear deletes everything inside the map. And method isEmpty checks if the map is empty or not. Here we can see phone book where phone numbers serve as keys and names associated with them as their corresponding values. By applying method values, we can see it returns all the values in this map without holding the insertion order. We can see it right here and there. KeySet method returns all the keys this map contains also without insertion order. And by printing the whole hash map by its name, it prints entries with no insertion order. We can iterate hash map with the enhanced for loop and pretty simple syntax. We can see it right here and the result of it right there. For the most concise and elegant way, we use for each method with lambda for iterating the entire hash map. And if hash map needs to be sorted, the easiest way to put it inside the constructor of a tree map. After that, by iterating this tree map, we can see that this tree map sorted all keys it contains in ascending order. And we can see the result of it right here, as tree map intended to do. So, thanks for watching. If you find it helpful, please hit the like button and see you soon.